Is
Did Catherine? There you are, Catherine. Catherine, we can't hear you.
Oh,
Katrina.
apologies. I was on mute, sorry. Yeah, I will look out for whatever Dane would like me to look out for. I will double check the agenda for there's a purpose indicated, goal of the.
Oh yeah, I sent you a message on the group chat. I don't know if you're able to see it.
Yeah, there is a message. Yeah. No, only the question about the word of the day, whether it's inclusive or inclusion, but no specific message. No, yeah, I will. If you like
yeah,
to,
so I could just share with you, Catalina, because I know you just jumped in. So yeah, I'm just looking for like connection with the audience, deeper understanding of more complex concepts, and using descriptive detail.
Connecting with the audience, descriptive detail,
and conveying like deeper concepts.
Deeper concepts, okay. Mm-hmm.
Thank you.
Watch out for that.
Wonderful, thank you. As some of you may remember from Dane's icebreaker years ago, he used to work as a mechanical engineer. During his time at UCI, Dane studied many aspects of mechanical design, and today he's here to share about a certain type of system that has more to teach us than you may think. Give it up for Dane with Marginal Stable System. Marginal Stable System. Here is Dane.
Okay. I am going to share my screen. Just a moment. So, can you see this?
Yes.
Okay. Can you see? Okay, you can see this video. All right. All right. So, how many of you are engineers? I figured we had a few in the club.
Me.
I know that I've heard from many of your stories, and I know we've had some engineering light shed on this club before, and I really want to share about one thing that I learned about this terminology. We learned so many terms in engineering in our engineering degrees, but one thing that I know other engineers might be familiar with as well is the concept of a marginally stable system. And to share with you a marginally stable system, I want to share this video with you to show rather than tell. So this is the robot dog. How many of you are familiar with the robot dog? Yeah. So Boston Labs created this robotic dog. They put together an engine, they put together control systems, they put together all this crazy stuff to make this robotic dog walk, much like a real dog. So this dog can walk over all kinds of terrain and can go down hills, can climb up stairs, can even run, and the poor dog can get kicked and still stand up. So this is what you might call a marginally stable system. And what's fascinating, I think, about mechanical engineering and engineering in general is that so many of the concepts inside of it can be applied to the whole entire world. So just like Spot here, walking around and getting kicked over These engineers have designed this to be in harmony with the world around it. So even if the strongest wind blows, Spot won't fall over. Even if somebody comes up and kicks, a human might kick him. He won't fall over. This is a marginally stable system. Now, what's fascinating about marginally stable systems is that they have bounds, right? So they have bounds. So when this Spot here, if you were to hit him with a semi-truck, he might tip over. So Spot is designed to live within inside of bounds, certain bounds, right? And these engineers have tried to maximize these bounds that Spot can live inside of, so that he can maximize the harmony and indestructibility that he has. Now, marginally stable systems are all over the place if you really look. I recently, this last weekend, procured a bunch of indoor plants. My girlfriend's sister, at their office, all these plants were dying. And these plants had been indoors, and thankfully people had been watering them. And so they said, hey, you guys can come pick up these plants. So I went up and picked up these plants, and I was so stoked to have these plants. And when we got back down here, we were like, oh, these can be outdoor plants as well. So maybe we could just put them outside. We put them outside, and we looked out the next day, and the plants were burned. They were broken. These plants were designed for a system of tranquility. They were designed for a system of ease. No wind, not too much UV, a nice, easy system. A system with limited bounds. However, when I brought them down here, I maximized the bounds. I put all kinds of strain on these plants, and they started to die. They became unstable. See, that's the point of the marginally stable system. And if we look around, they're all over the place. If you balance a pencil on your finger, can't do it for very long, it can be stable for a short period of time. But then, based on my skill level, based on my ability to balance this pencil on my finger, it might fall over. So what's fascinating about these marginally stable systems is that they can be also applied to people. As many of you know, I've shifted away from my engineering career, and now I work with people. And I find that there's such a similarity between mechanical things and the way they work, and people and organizations and how they work. And what's fascinating is that all of us are a marginally stable system. The entire world of people is a marginally stable system. And while instead of having control systems and sensors and circuits and computerized systems holding up this dog, which I realize I need to stop sharing my screen, holding up this dog, it's different with people. We don't have control systems. We don't have sensors. We don't have engines. But what we do have is leadership. We have trust. We have camaraderie. We have listening. These are the things that hold people together. And by maximizing these things, we too can become even more marginally stable. Thank you so much. Back to you, Shabnam.
Thank